These videos were generated locally with LTX 2.3, no cloud, no subscription. And this effect, it's called a transition LoRa. Let me show you exactly how to set it up. LoRa stands for low rank adaptation. Think of it as a small plugin, around 400 megabytes, that sits on top of your base model and changes how it behaves. The base model stays the same. You just load the LoRa on top. Once you learn how to connect one LoRa, you can connect any LoRa. That's what this video is about. I bring you quality content. All I ask is that you subscribe and leave a like. That keeps me motivated to make more unique videos and share secrets you won't find anywhere else. This is the Transition LoRa by Valiant Cat. Great for character morphs, style shifts, and scene transitions. HuggingFace link in the description. Open your ComfyUI folder. Go to Models. Then open loras. Paste the LoRa file here. If the loras folder doesn't exist, just create it. Keep the workflow file somewhere easy to find. We'll load it into ComfyUI in a second. Open ComfyUI. Now drag the JSON file directly into the browser. The workflow loads automatically. All the nodes are pre-connected. This node here is load LoRa. This is the key piece. It's wired between the base model and the sampler. Click on it and make sure it points to the transition file. 3 settings to know. LoRa strength. Keep it at 1 to start. This controls how strongly the LoRa influences the output. Go higher and the effect gets more dramatic. Go too high and artifacts can appear. For image conditioning, leave it at the recommended value for now. For CFG, leave it at the recommended value for now. These are good defaults. We'll test with exactly these numbers. Now the most important part, the trigger word. This LoRa has a special word, ZHUANCHANG. Always put it at the very end of your prompt. Without this word, the transition effect won't activate. Let me show you the exact prompt structure. Shot type first, then the subject and scene, then the transformation description, then the lighting and atmosphere, and finally the trigger word. Settings are locked in. Let's run it. This is the cold run, the first generation of the session. Watch the VRAM counter as the workflow starts. I'm speeding up the middle here, but this is the real benchmark pass you're seeing on screen. For this run, we are using the full 24GB setup with Gemma API and the transition LoRa at strength 1. The exact benchmark settings are on screen. The exact runtime and memory numbers are on screen. You can use that card as the reference for this benchmark. And here is the final output from this cold run. Now we run it again. This is the warm run, so the model is already in memory. The workflow is the same, and the visual result should stay consistent. I'm speeding up the middle here, but this is the real warm benchmark pass you're seeing on screen. For this run, we are still using the full 24GB setup with Gemma API and the transition LoRa at strength 1. The exact benchmark settings are on screen. The exact runtime and memory numbers are on screen. You can use that card as the reference for this warm benchmark. And here is the final output from this warm run. Now we move to the 8GB path. The method stays the same. The hardware class changes to 8GB and the model changes to Q3. Now we move to the 8GB class. Here the setup had to be reduced. Q3 Gemma API 73 frames, 960 by 512 and 24 steps. This is a cold start, so the model is loading from scratch. I am speeding up the middle, but what you're seeing on screen is the real run. The exact time and memory numbers stay on the card. And now I will show the full final result from this generation. Warm run on the 8GB setup. Same Q3 model, same Gemma API, same prompt and the same transition LoRa. This time the startup cost is gone, so the run finishes in 230.94 seconds. On the visible stats panel, VRAM peaks at 19.6 GB and RAM peaks at 21.3 GB. I am speeding up the middle, but this is the real warm run. And now I will show the full final result from this generation. Here are the full numbers. 24 GB versus 8 GB side by side. The LoRa works on both. If you're on 8 GB, you can use loras, but there is a trade-off. To stay within the 8 GB VRAM limit, I had to reduce the test to about a 3-second generation, and the transition became less smooth. You can try longer generations on an 8 GB card, but then it may no longer fit cleanly into that VRAM class, and render times will increase a lot. Starting from 12 GB of VRAM, the results already become noticeably better. You just need the GGUF model and the Gemma API setup. Both are covered in part 2 of this series. Link in description. The free workflow for this video is in my free group, link below. And if you don't want to set this up manually, the auto installer already has this LoRa integrated. It detects your GPU, downloads the right model, and the transition LoRa comes pre-configured one click. This is the easiest way to see what the LoRa is doing. Same image, same prompt, same seed. Left side no LoRa. Right side transition LoRa at strength 1. Without the LoRa, the transformation is weaker. With the LoRa, the change becomes much more obvious and much more consistent. So yes, the LoRa is doing real work. Now you know how to connect any LoRa to LTX 2.3. This skill works for every LoRa that comes out, not just this one. Free workflow and free group, link in description. Auto installer with this LoRa pre-integrated, also in the description. Subscribe for the next benchmarks when new LoRas drop. See you in the next one.